So now we want to compute this integral. So there's things that we need to consider. So we're dividing by something, and whenever we divide by something, there could be problems if that something is 0. Okay, so let's think through this. Is x ever equal to 0? The answer is yes, it's equal to 0 when x is equal to 0, but we're not integrating over that domain, so there's no problem there. What about natural log? Is natural log ever equal to 0? Yes, it's equal to 0 when x is equal to 1, and then there's an asymptote when x is equal to 0. We're not integrating when x is equal to 0, but natural log of x when x is equal to 1 is equal to 0, and so this function has an asymptote at 1 of the endpoints of the integral. So this is an improper integral, and so here's how I'm going to do it. The integral, so you need to be, so here's something that is very important. I left off a dx here, that's important, but not what I was going to say. You need to very precisely write the limit exactly when you should, and not write it when you shouldn't when you're computing this integral. So I'll explain as I go along. So this is defined as the limit as t approaches 1, and so let me do the number line here. Okay, so let's say this is 1, and this is e. Okay, so we're going from 1 to e, so the t value is going to go that way. So we're approaching 1 from the positive side. And it's going to be the integral t to e. So again, like if this is t, we're integrating over this integral. When we integrate over the integral from t to e for any t bigger than 1, this is going to be a proper integral because on that interval, 1 over x log x is continuous. We're going to compute that using our normal integration rules for every value of t. We'll get a formula for t and take the limit of that as t goes to 1. But for now, we're going to have dx over x natural log of x. Okay, now for a moment, don't keep writing the limit here, but let's just look at this integral. If this is the integral that we were given to do, how would we do this integral? I think that we would do it by integration by parts. I think we would do this by u sub. We would say that u, let me do a little scratch work over here. We would say that u is equal to the natural log of x, and therefore du dx is equal to 1 over x. So du is equal to du is equal to dx over x. Okay, so now I'm going to change the stuff in my integral. I'm going to keep the limit here as the same. All of this u sub doesn't affect this part at all. So I'm going to keep this and then make all the changes that I need to in the integral. So I'm first going to change the integrand. So natural log of x, that's u. Notice that dx over x, that's equal to du. So when I change the dx over x is equal to du, so I have a du there. And now I need to change the limits on the integral. So u is equal to the natural log of x. So this is going to be the natural log of t to the natural log of e. The natural log of e is 1. Okay, and so this, again, we're not really doing anything with the limit so far. Okay, so the antiderivative of 1 over u is a natural log of the absolute value of u, but 1 is definitely positive. Now, t is bigger than 1, so the natural log of t is bigger than 0. So this is natural log of 1 minus the natural log of the natural log of t. Okay, so the natural log of 1 is 0. So this is the limit as t approaches 1 from the positive side minus the natural log of the natural log of t. And so now we need to think what's going on here. Okay, so first of all, I can put the minus sign like this. Okay, so we need to be careful with how we're going to reason here, because we know that the natural log function is continuous, but we see some weird things going on over here. And since we haven't really talked too much about continuity from the right and things like that, I want to be careful with how we think about this. So as t goes to 1 from the right-hand side, so as t goes to 1 from the right-hand side. So as t goes to 1 from the right-hand side, let's think about what's happening to the natural log of t. So as t goes to 1 from the right-hand side, so this is I'm going to give a graph of the natural log of t Okay, so the graph of the natural log of t looks something like this. This is 1. And so as t approaches 1 from the right-hand side, so as t approaches this way, natural log is approaching 0 from the right-hand side. So as t approaches 1 from the positive side, the natural log of t approaches 0 from the positive side. Okay, so the natural log of t is approaching 0 from the positive side, which is good because that's where log is defined. So I've got a log on the outside, a log on the inside. The inside log is approaching 0 from the positive side. So the natural log of something that's approaching 0, okay, so now look back at the natural log function. So now this is the natural log of t. Now I'm going to look at the natural log of the natural log of t as the argument here is approaching 0. So as the argument is approaching 0, notice that natural log is approaching minus infinity. So as t, so there's a bunch of stuff going on here. As t approaches 1 from the right-hand side, natural log of t approaches 0 from the right-hand side. So the natural log of t approaches minus infinity. And then I have a minus sign there. So overall, this is equal to positive infinity. Okay, and I think the answers, I forget what the answer choices are in the exam, but for this one, it would be positive infinity. Somewhere around here, you might recognize that, okay, the integral is going to diverge, but we get just a little more information and think through just a little more. I agree, it's kind of complicated. We see that, it diverges to positive infinity rather than negative infinity. Another way to view that, if this is a multiple choice test and right around here, or at some point you figure that it diverges, notice that on this domain of integration, x is positive, but natural log of x is also positive. And so if we're integrating a positive function and it diverges, it has to go to positive infinity.